The recording has just started. Okay. I'm sure a lot of these guys are the same people, but in case, I know there are some new people, new IP editors, whatever, that are here. So remember, when you submit questions, remember to follow these guidelines. The first thing is, if you submit a specific problem, you absolutely, bar none, you absolutely must quote the source of the problem. We had about 15 people submit problems in the last 2-week interval that had no source, and so we just can't use those. Like, they gave us, a question with 5 answer choices, and it was, it looks like a GMAT problem, but we don't know what the source is. Because the issue is that we can't really violate copyright here. I mean, remember what we can't do OG problems. MGMAT problems are fine. GMAT prep problems are okay. Notice that these are official. So if you want to submit official problems, then those are okay. And then basically the deal is that for a complete list of sources that we can't use, go to our forums, which is manhattangmat.com/forums, and then go to either the general verbal or general math folder. And, sorry, that's a typo, I'll fix the address in a second. And then click on forum rules, which is the first post in each folder. It's a sticky. On that post, there will be a list of, that's for the forums, but the same sources that we can't use in the forums, we also can't use here either. That's guideline number 1. If you submit a specific problem, we can't use it if you don't tell us where it's from, because this is a free service, the study hall, and so since anything we give away for free, we absolutely are not allowed to use sources that people have to pay for. So, smiley face if you guys understand this when you submit problems. Okay, I mean, it's really important because I see 1 thumbs down, which presumably means I wish we could, but in this field, copyright is taken pretty seriously. So, yeah, we gotta follow the rules. And then the other guideline is this. GMAT Focus is also not okay because GMAT Focus is a paid product. So, because again, this is and GMAT Focus is probably even less okay because the cost per problem is much higher. So they would, if they were to come after us for that, they would come after us for a lot more than they would from an OG problem. Because, GMAT Focus is $25 for 24 problems. OG is $25 for like 800 problems. So yeah, GMAT Focus is even worse. But if it's a paid product from another company, you should be a little bit chary about posting it here. Just be aware of that. What you can do, let me go ahead and type this here before we type rule number 2. What you can do, and what people do on the forums a lot of the time, is you can basically make your own version of the problem. Put your own spin on the problem. So if you have quant, you can do the same format, but maybe different numbers or specifics. And if it's verbal, you can basically, if it's a sentence correction, you can do the same, sentence structure, but different specific nouns and verbs and so on. And then that's okay. Now, if you do this, I still want you to give me the source of the problem that you are imitating so that I can still look at it. So still in your submission, still quote the source of the problem. that you are imitating. Because, you know, students aren't really going to invent problems from whole cloth. I mean, what we've had is submissions from people who submitted problems that were pretty clearly spin-offs of OG problems, you know, which is okay. I mean, that's what we're telling you that it's all right to do, because then we're not stealing problems. But these students would say, I just made up this problem totally by myself, which is basically a lie. I mean, you could tell they were taking the OG problem and spinning it. So if you do that, that's fine. That's not a problem. But if you do that, then just make sure you tell me where you're getting the problem from. Because otherwise, if you give us an unsourced problem, then we have to reject it. That's copyright. That's how it works. And then the other thing is when you submit a problem, remember this is a study hall that's attended by upwards of sometimes 30 or 40 people at a time. So you don't want to make your problems way too specific. Like try to ask some sort of general question along with your query. So for instance, if you are, like if it's just a problem that's like, why is choice C wrong on this problem, I'll still look at those. And if those give rise to any very interesting principles, then I can pull those principles out and post them. But in general, things like, if it's just a question about one answer choice to one problem, then that doesn't really belong in the study hall. That's more the kind of thing that belongs on the forum. So in fact, that's kind of the entire reason that the forum exists. And remember that anything that's not okay on the forum is also not okay here. So if you have a problem that is extremely specific, like one answer choice of one problem, please post that issue on the forum. You know, so it's basically like, would it be okay to present this issue to a class in front of, 40 students? If it's one query about one problem, one answer choice, probably not. Unless it illustrates a very, very general principle, in which case I may still pull those and use them. But if you post a more general query based on a problem, then there's a higher chance that we'll use it in the study hall. Like, here's a combinatorics problem. How do you solve this? And what's some general strategies for these sorts of problems? That's a good kind of question. If it's just, where's the 4 factorial coming from in this one problem? Forum. Okay, smiley face if you guys understand that. Okay, those are the general rules. So I think you guys are on this, but I just feel, and if I'm reiterating, then, I apologize for that, but more than half the submissions in the last couple of weeks basically fell into this template. They were either, looks like people are moving things around. Okay, let's not do that, please. Thank you. Okay. More than half the submissions these last couple of times were in violation of one or the other of these principles. They were either unquoted problems, which was most of the issue, or they were like extremely, extremely specific. Okay. So let's move on to the actual material of the study hall. Let's start talking about rate, time, and distance problems. So here we go. Systematic approach to rate, time, distance. And notice that we're not just calling them rate, time, distance problems. We're actually calling them rate, time, distance style problems because, as it says on the slide, there's actually a whole genre of problems that have exactly the same form and thus can be solved in exactly the same sort of way. So notice, here's the deal. The deal is that when you have a rate, time, distance problem, the ultimate setup of the problem is rate times time equals distance. So the overall setup of this, what matters is not so much that these quantities were called rate, time, and distance. Now, if we were in some alternate universe where we renamed the concepts of rate, time, and distance, then as long as they still had the same relationship, we could still take exactly the same sort of tack on the problem. We could still take the same approach. So this format is the key point here. And as long as you're dealing with problems that have this sort of setup, you can use the same techniques that we are about to broach for rate, time, and distance. So in the text box, let's take 30 seconds. Can anybody in the text box think of any other 3 quantities that are related in this same sort of way? In other words, quantity 1 times quantity 2 equals quantity 3. If you can think of anything, go ahead and type it in the text box. I'll give you a little while to think. Okay, I like what we're seeing. A couple of you are saying speed times time equals distance. That's basically the same as what's up there. So it's correct, but it's not really anything new. A couple of you are citing, yeah, work rate times time equals total work output. As an example, if you're talking about publishing a book, then you are working with like for instance, pages per hour times hours equals total pages. Another example, which is the next one cited by a lot of you, is cost per unit times quantity equals total cost. So dollars per item times number of items equals total cost. What we're missing here, which we can go ahead and add in, is sample units for the first thing, for rate times time. For instance, this could be something like miles per hour times hours equals miles. That's an example. Here are some other things that satisfy the same template. So when we said at the beginning of the class, we called them rate, time, distance, and friends, the and friends refers to all of the other types of problems that work in exactly the same way, even though they are not technically problems about rate, time, and distance that work in the same sort of way as RTD, even though they do not technically involve rates, times, or distances. So here's a few more of those. Hourly wages times number of hours worked equals total pay, which is, it's very closely related to the last one. I mean, both of them are dollars per something. Miles per gallon times gallons equals miles driven. In general, here's a big hint. If you see anything that's unit 1 per unit 2, you can usually use this kind of approach. So, like if you see unit 1 per unit 2, that's a pretty good indicator of this problem type. And then finally, a big one, the percent ingredient mixture type problems. Those are also rate, time, distance type things. And then not to be outdone, this is a huge one. A lot of problems involving arithmetic mean and count and sum. So all of these are essentially the same template. So smiley face if you guys see how these quantities are related in the same way as are these. Okay, here's what we're going to do. What we're going to do is we're going to work through a problem together, and I'm going to illustrate my approach to these, which is a 7-step approach. And if for any of you who have our materials, our strategy guides, and so forth, the best way to think about this is not as a substitute for what is in the strategy guides, but more as a supplement. In other words, the strategy guides give you the grounding, the basic facts that you need to do this kind of stuff. So, but my method that I'm going to give you today is it's more systematic than what is in the strategy guides. It doesn't contradict anything in the strategy guides, but it still uses the same charts, etc., but it's more systematic. So let's give it a whirl on this particular problem. Smiley faces if you can see the problem. We've had a few problems with text boxes, but okay. We're going to go through the 7 steps one at a time, and I'll illustrate exactly what they are. The first step of this method is to create a chart. Okay, the chart is the same sort of chart that you would create according to the strategy guide. So, identical to the charts in the strategy guide. So who knows, in our strategy guide, I know that not everybody here owns the strategy guides, but rate, time, distance chart, this is literally rates, times, and distances. So what in the text box, what would go on top of the chart as per our strategy guides and most other sources? What's going to be the heading of that chart? I see a couple people typing. I don't think most people are typing. Nobody? Okay. The heading of the chart, as per our strategy guide, is rate times time equals distance. You just put whatever the equation is that governs the problem. So if the problem is rate, time, distance, then that's what goes on top of your chart. And if you have any of these friends, then you put those on the chart instead. So it might be wage times hours equals pay, or miles per gallon times gallons equals miles driven. But whatever the equation is in the format, this times this equals that, that goes on top of the chart. Smiley face if that makes sense. And then the rest of the chart, you do need to, I'm going to use a little bit more. When you're drawing these at home, you probably don't need to make quite as many lines, because after all, it takes time to do that. But you also need the rows. Each situation gets its own row. Okay, so let's put the words over there. Equation on top. And each situation equals a row. That's supposed to say top. So there are 2 situations here. Sometimes it's different people, sometimes it's different days, different time frames, different whatever. But how am I going to label these rows of the chart? Does anybody know? Text box if you know how I'm going to label the rows of the chart. Yeah, I hear, a couple of you are saying it, day 1 and day 2. So there's the chart. Then, any questions about step 1, create the chart? Any questions? Okay, let's look at step 2. Step 2 is to fill in concrete numbers, hard numbers I call them. Now be careful with this, because hard numbers doesn't mean every number they give you in the problem. So hard numbers, this only means numbers that you can fill into these slots. So i.e. numbers that actually go into the cells of the chart. So we got to be careful here because a lot of the numbers given to you in the problem do not go into the cells of the chart. For instance, this number, 1 mile per hour, does that go into any of these boxes, yes or no? Smiley face if it does, other face if it doesn't. Does this 1 mile per hour actually go into any of these boxes? It doesn't. So this is not a hard number. This is what this is a relationship between these times. We'll get into that in a second. Also, total of 64 miles. Does that go yes or no, smiley, or not? Does 64 go into any of these boxes? So a couple of you are smiling at this. No, it does not. Because this is not the distance on the first day, and this is not the distance on the second day. So this is a total distance that's also not a hard number right now. All right, smiley face if you guys understand that. This does not actually go in any of the boxes of the chart. That's very important. This is a relationship. And so is this. Now, the mileages you can't figure out right now, but sometimes you have to just get stuff out of this statement. For instance, if you spend a total of 18 hours walking and you spent 2 hours longer on the second day, then you can just figure out the actual hard times. Does anybody know what those are? Like if you have 18 hours total, and the second day was longer by 2 hours. Can anybody just spit out those numbers? It's 8 and 10. So if you had to use equations to figure out that kind of thing, you could, but hopefully you don't have to. Hopefully that kind of thing you can just sort of eyeball it and figure it out. So 10 hours. So what we've used is we have used up this information. We've used the 2 hours longer, and we've used the total of 18 hours. Those are hard numbers. Now, here's the key step. If you use this method of 7 steps, then all of the kind of cortex activity that you need, all the thinking that you got to do, is going to happen right now in step 3. Step 3 is to find the relationships between the unknown quantities and then in words. Don't define a variable yet. So the way that I do this in my 7-step method is I just use the word relationship, and I actually create a separate row of the chart that says relationship. So, you know, it's like having a third row in your chart, but we're going to fill this row with words instead of with numbers. Now notice it's only between unknowns, so we don't need any kind of relationship here because these are not unknowns. Okay, but who can give the relationship between the rates in words? Can anybody do that in the text box between the rate for day 1 and the rate for day 2? Yeah, I like Anthony's response. A couple of you are defining variables. The whole point of this is that you really don't want to define variables yet. Because if you do, you're going to wind up with 2 variables. You're going to wind up with a variable over here and a second variable over here, and then you're going to thrash around having to eliminate variables. Remember that the thing you absolutely do not want is to have to eliminate a second variable. So we want words. So second day is 1 mile per hour faster on the second day. What's the relationship in words over here in the text box, please? the distances. Okay, nicely done. The relationship's got to be precise. You can't just say more miles. That's a true statement. He does walk more miles on the second day because he walks longer and faster, but that's not what we mean by a relationship. It's not just more or less, because that's not something you can work with. The precise relationship is that the sum of the two mileages is 64. Smiley base, if you guys understand this, in particular I'm looking for smileys from the people who put stuff about more or less. Because those are not things that you can use to solve a problem. I mean, you can use them maybe as like a check when you're done, but you can't solve the problem with that. So be precise. Now notice the whole point here is not to use two variables. That's the whole point. You do not want r and r plus 1 and d and 64 minus d. Because if you do, you've got two equations. And unless you are lightning fast at algebra, that's hard to work with. Step 4, this is where you get into the variables. Define one variable, not two, from a relationship. So now we can do what a couple of you guys did in the text box earlier. Let's take this and make a variable from it. So now we can do the r and the r plus 1. It actually doesn't matter which relationship you use, and so we'll illustrate that later on the next slide. But you do not want a second variable. You just want to do this. Also, there's no problem with making this r over here and then r minus 1. Although your average speed in the first day, this is what we want. Smiley face if you guys understand how we define this variable. There's another study hall edition, by the way, on single variables. Because some people are even going to do things like x and y, where y is x plus 1. Way too much work. If you have a simple relationship, one variable is what you should use. Does anybody know what we're going to do next, instead of defining a second variable? Yeah, you fill in the rows, right? The whole point, like the entire reason this chart exists in the first place is precisely so that you do not have to define a second variable. That's the whole reason for the existence of this chart. So in this case, it's multiply. So use the equation on top of the chart to fill in the rest of the rows. So this is 8 times r, and this is 10r plus 10, because that's how these are. This times this is this, and that times that is that. Then, this is why we list the relationships, because once you have those relationships, you should take the leftover relationship and write an equation. That's the beauty of it. You usually wind up with, one set of hard numbers, then you wind up with two relationships. One of them gives you a variable, and the other one gives you an equation. So in this case, it's the sum of the two mileages is 64. So you just write an equation based on that. Let's do that. There's not a lot of space left on the screen. But sum of mileages is 64. So that means that 8r plus 10r plus 10 equals 64. And then finally, step 7 is you got to solve the equation. So, and perhaps plug back in. So in this case, you solve that equation. If you have 18, R is 54. So R is 3. And in this case, the answer to the problem is actually R, so you don't have to do any plugging back in. Does this make sense? Smiley face if you guys follow this whole sort of approach. Okay, now, what is cool here is, again, remember what I said, all right? You know, your good old cortex in your brain. The only time you really, really have to activate that cortex is for step 3. And this is the reason I like this method. Because with other methods, these thought processes don't really happen at precise times. Like, you know, because the only two things that you really have to figure out in this problem, aside from these numbers right here, are this and this. And so if you make yourself do that, then you can absolutely pinpoint where the trouble is that you're having with these problems. Like if you can't fill in this relationship box, then that's the problem. But that's exactly the part of the problem that you don't understand, which is very cool. All right, so one more point I want to make about this, and that's the following. Let me see if I can do this. Let's see if I can copy and paste here. Okay. Let's try something else. Notice that there's nothing here saying that we have to, because we just said choose a variable and run with it. And there's nothing here dictating that the variable has to be this one. So let's illustrate that if you wanted to, you actually could go the other way. So let's give a brief summary of the 7 steps over here. The first one is create a chart. The second one is put in hard numbers. The third one is find relationships. So we've already got those 3. And then step 4 is define a variable. One variable. Then step 5 is to fill in the rows, fill in horizontally, complete the chart. And then you write an equation from the leftover relationship. And then you solve. So let's do the rest of that, but let's just use the other variable. So it shows us that we don't really have to, we don't have to worry too hard about what we're picking as a variable. I mean, eventually this quantity right here is what we want. But that doesn't mean we have to define that as a variable. It just means that that's what we're interested in at the end of the problem. So does anybody know if we decide to define our variable based on this instead, who knows what I would call these if I'm going to define a variable based on the sum is 64. If I called this D, then what would this be? Anybody know? Yeah, D and 64 minus D. Well, 24 and 40 is once you've solved the problem. We're going back to step 4. We're saying, what if I chose this variable instead? So you can't give me a 24 and a 40 because that means you've already solved the problem. So smiley face, if that makes sense, who's the person who's put in 24 and the 40. Okay, good. So yeah, we would call these something like D and 64 minus D. Now, who knows, to complete horizontally is not as much fun here, but it's not horrible. What operation do you have to do to get over here? If rate times time is distance, and you have distance and time, then what do you have to do to find rate? Yeah, you got to divide them. if this is unclear to any of you, then just think about like 4 times 5 equals 20. Then think about what you would do if you had a 20 and a 5. You have to divide them. So this is going to be d over 8. And this is going to be 64 minus d, all divided by 10. I mean, it's a little awkward, but it's not horrendous. And if it, if it works, it works. So this time the leftover relationship is the other one. This time the leftover relationship is 1 mile per hour faster on the second day. So second day is first day plus 1. This is second day rate equals the rate for the first day plus 1. So this would be 64 minus d over 10 equals d over 8 plus 1. So there. One student is asking, can we always do this or that? Guys, pretty much the answer to can we always do this is pretty much always going to be no. I mean, that's kind of the whole point of this test, is that you're not going to be able to memorize your way through this test. So be careful with that. I mean, if this would work on every single problem you ever came across, then I wouldn't bother showing you the other way to do it. So no, because in some cases you're going to have to divide. I mean, like in some cases you'll have hard numbers for distance. So if you have hard numbers in here, then you're stuck with defining variables in these two boxes, and you're going to have to divide. So I mean that can totally happen. It doesn't happen in this problem, but it's very possible. So okay. This is a fractional equation. It's a little bit more annoying to solve than the other one is, but who knows the first step of solving? Let's see. Margaret, I'm sorry, I don't understand the question. I don't know what D, what is D? You said is D the same thing as? So if you could please retype the question. Okay. Yeah, you get rid of the denominators. Who knows what we multiply by to get rid of the denominators? Common denominator. Common denominator is 40. So we need to multiply both sides by 40. That's what you do. So that gives you 4 times that's 256 minus d, 4d, equals 5d plus 40. So you wind up with 216 equals 9d, and so d is 24. And so then the answer you want is d over 8, which also works. Okay. I'm not getting a response to this. A student typed. I'm going to go ahead and type this in the text box. The student typed, is D the same thing as? I think that's what that question was supposed to mean. No, D is distance. D is not speed. So if that's the question you're asking, then you could call any variable by any letter you want, but if that's what your question means, then no, D is distance. It's not the same thing as speed. Okay, does everybody follow this explanation? It's the same 7 steps, but we just defined our variable differently. Any questions about this? Okay. Let me try to throw. Is the formula the same thing? Yeah, I mean, rate times time equals distance. Yeah, if you divide both sides by time, that's what you get. Oh, okay. I think I get it. I think you're using this to mean that. Please don't do that. If you have questions to type, please type the question out with whole words, so that I don't really understand internet abbreviations. So please, thanks. Okay, yeah, it's the same formula as speed equals distance over time, because if you just divide both sides of the equation by speed, that's what you get. All right, so smiley if that takes care of your question. Smiley icon. Does that answer you? Okay, good. Good to go. All right, any questions about, by the way, yeah, guys, on the forums, when you type on forums, please do not type the following things on forums. Please do not type D for the, do not type could or would. Please do not type positive or negative like this. Please write these words out. Especially CUD and WUD. I mean, it takes like half a second to write out the complete word. So, and then it makes the post about 3 times easier to read. So please don't use these abbreviations. Okay, let's move on. Let's try a data sufficiency problem. Here's what I'm going to do. This is a little bit different for data sufficiency, but I want to see how you guys do. So what I'm going to do is turn on the polling. So if you look in the upper left corner of your screen, you should see A through E answer choices up here. So when I'm going to give you time to do this. When you finish, please indicate your answer to the problem with the buttons A through E at the top left. In other words, please do not indicate your answer in the text box, because everybody will see that, and that's not what we want. We want your answers to be private. So I'll give you a timer for about 2 minutes, and we'll see how we do. Go for it. Okay, ladies and gentlemen, let's please indicate an answer of some type, even if it is a guess. Remember, that's how the GMAT works. It makes you answer the problem somehow. So this looks pretty good. I'll show you your polling results briefly. There's one student, Anthony. Anthony doesn't have an answer. Please go ahead and answer. Remember, no one sees what you guys pick, so if you have to guess, you still want to get into the habit of actually guessing. Because the worst thing you can do is get paralyzed. Here's your polling responses. There they are. Sorry, I didn't mean to do it that way. Okay, here's your polling responses right here. Most of you got this correct. So let's look. How does the 7-step method apply? So let's put this down over here in the corner. Well, there's a difference. There's one major difference, which is this. How many charts do you have to make when the problem is data sufficiency? Go ahead and type in the text box. What's different about applying the 7-step method to data sufficiency? Yeah, you're going to want to make two charts. Because remember, statement 1 and statement 2 are different sets of information. So you don't want to use the same chart. You want to use one for each of statements 1 and 2. If you get to C versus E, you won't need a third chart, because that's just combining the two. So you can just import the data from one of the charts into the other one. Now, this might seem like it would take twice as long as making one chart. I mean, if you think that, I totally understand why you would think that. Because, you know, it's two charts. I mean, you might think that two charts would take just twice as long as making one chart. But remember, it won't, because this will not take twice as long as two problem solving. Because two main reasons. The first is, well, there's three reasons. I mean, the hard numbers and prompt are the same. So once you figure those out once, you don't have to figure them out again. So it's going to take less time. Most importantly, you don't have to solve if you get an equation that's going to work. And then if a statement is insufficient, then you'll usually just stop. You'll usually just get stuck and have to quit. So what I mean is, like, if it's data sufficiency and you see this equation, you're done. You can say, look, I know that has a solution. I don't have to solve that. Whereas on problem solving, you've actually got to grind it out. You've got to do the multiplication, get rid of the fractions, collect the terms, do the division. You have to do all this work. On data sufficiency, you don't have to. As soon as you arrive at an equation, and then you're done. So again, here are the 7 steps. This time I think I can type them all in the same color. So I think we're good here. Number 1 is chart. Number 2 is hard numbers. Number 3 is relationships. Number 4 is one variable. Number 5 is fill in horizontally. 6 is leftover, gives you an equation, and 7 is solve. So let's try this. Statement 1 and statement 2. Now what you should probably do is make them at the same time. So rate, time, distance, rate, time, distance. Who knows what the labels are for the rows? Go ahead and type in the text box. This first 200 and last 200. For the first one, yeah. So for statement 1, you've got first 200 and last 200, but not for the second one, because the second one doesn't have any of that. So who knows how to label the second? Yeah, the second chart is actual versus hypothetical. Because you've got, so if you were going to combine these, you would have somewhat of an issue. But it's not, because the second one doesn't talk about the first and last 200 kilometers. So instead, it talks about if this had happened, then here's what would have happened versus what really did. So everybody give me the smiley icon if you understand that these are appropriate labels for the first chart and these are for the second chart. And you can give me the other face if you don't understand. Okay. So you can go ahead and type questions in the text box. I'll try to hit them in stride here. But so for the first question, we've got the distance. The total is 400, but You don't need that. These are hard numbers. 200, 200, those are hard numbers. So we don't need a relationship there. But we have the first 200 is in 2.5 hours, and then 200 divided by 2.5 is 80 is what that works out to. So, but then there's no relationship at all, and there's no relationship at all. So that's going to be insufficient. But there's no relationship whatsoever. Okay, smiley face if that makes sense. So statement 1 is not going to work. Okay, so because what you want is you want the total time. So that would be the sum of these. Here all you want by contrast is a little bit different. In this case, what you are after is just the actual time for 400 kilometers. So hard numbers in this problem, the actual distance is 400 kilometers, and the hypothetical distance, because it's the same trip, is also 400 kilometers. So we don't need a relationship there because that's hard numbers. Who knows in the text box what's the relationship between actual and hypothetical as far as rate? Can anybody type in the text box? Actual rate versus hypothetical rate. Yeah, the hypothetical is 20 faster. So the hypothetical is 20 kilometers per hour faster. So that's supposed to be an equal sign. That's a relationship, and then the relationship between the times is it would have taken 1 less hour. So hypothetical equals 1 hour less. Remember, we really don't want 2 variables here. In fact, in data sufficiency, you are much worse with 2 variables than even in problem solving. Because here's the difference. If you can successfully use 1 variable, then as soon as you get an equation that you know you can solve, you are done. If you have 2 variables, you are actually going to have to solve the system, because with 2 variables, you can never really tell if you're going to get a solution or not. So your variables here are going to be, you can define this either way. It doesn't really make any difference. You're going to have to do division. So, and in fact, I forget whose question it was. I think it was Avanti, who was asking, can we always multiply? This problem proves that you can't because you have hard numbers in the right-hand column. So, but it's the data sufficiency problem. It doesn't make any difference. Because, I mean, even if you get an ugly equation, remember, you don't have to solve it. All you got to do is write the equation and then smile at it. So the rate is 20. Let's make our variable in the rate column just for, actually, let's put it here. Because this is what we want anyway. So hypothetical is 1 less hour. Since we have a choice, we might as well put our variable where at the thing we want anyway. That can help. So then we've got to do division. So this is going to be 400 divided by t. And then this is going to be 400 over t minus 1. So your equation is going to be 20 kilometers faster. So your equation is going to be that 400 over t is 400 over t minus 1 is 400 over t plus 20. So where the numbers will pop up in a second. 400 over t minus 1 is 400 over t plus 20. Now, depending on how familiar you are with the algebra, if you're not that familiar with these, you might have to actually do some steps to solve this, because this will turn into a quadratic, but one of the solutions to the quadratic will be negative and one will be positive, so it's sufficient. And then otherwise, if you recognize this kind of thing has a single solution, then you can call it sufficient. But if not, you can do it out. You get a quadratic. You get two solutions, but one doesn't count because it's negative. As far as the questions in the box, be very careful with that because sometimes there are two variable two equation systems that do not work. I know we discussed that at another study hall, but you can give what looks like two separate equations and two variables that doesn't have a solution, or you can give a single equation which does. So you got to be real careful with that. I mean, they write a lot of problems with that as a deliberate purpose of the problem. Okay, so this is going to be B, like you guys picked up on. Any questions? Okay, let's talk about something else. Let's move over to digits. In this case, we're going to take a little bit of a different tack. We're just going to, this screen right now is empty, but what's eventually going to happen is it will not be empty. How about that? Eventually, we're going to fill it with some strategies that work with digits. About 3 of you submitted digit problems, and 2 of you kind of asked, what can we do in general with digits? And also, if any of you are 9-session course students, our course is a little bit light on digits. We talk about it a little bit in the FTP class, so I feel like this is a pretty good supplement, even for people who are in our class. So let's do this. Let's do it based on problems. So why don't you try? Yeah, Paula says, at this point it is very difficult to know if the quadratic has an answer. I mean, this is true, although that's what I mean about being familiar with this type of thing. These are 2 quantities with different denominators by 1, and so if you work with that kind of thing enough, you'll realize there's only one t where this can work that's positive. Because if you shrink t, then basically the difference between these gets more significant, and if you raise t, then the difference gets less significant. So there's an intuition that goes with this. If you don't have the intuition, then the best way to do it is just to solve the equation and notice that it'll get one solution. I mean, you guys should have the skill set that solves this, that you can solve this kind of equation if you have to. So if you do find that difficult, and I can understand exactly why you would, then you should be able to do the math. I mean, it's a skill it's a skill set. The question asker, Paula, give me a smiley face if that makes sense to you. It's both ways. If you have the intuition, then great. If not, you should be able to do the algebra. So smiley face if that makes sense to you. Okay, thanks. Let's look at some digit problems. So right now this slide is empty. This slide will not be empty for long. Let's try this problem. I'll give you 2 minutes. Again, I'll clear the polling. Please indicate your answer again with the buttons. I'll give you a timer. Go. This one looks like fun. I know you guys can't see each other's answers, but we've got 4 people with answers, and the answers are 4. Actually, we got 5 different answers, and they're all different. So this one's going to be fun. Take another 20 to 30 seconds if you need it, and then when I call time, we'll be done. Anthony, you should see buttons in the top left corner of the screen that say A, B, C, D, E, and you can click those. We got 1 student who hasn't answered the problem. That is Belinda W. So if you are here, please indicate an answer, even if it's a guess. Because remember, when you take the test, if you don't know how to do something, you still have to guess. So if you're here, I'll give you 5 seconds to guess, and then we will review. Okay. I guess that student's not here. So here are your answers all over the place. Absolutely no clear majority of any type. Remember the none at the, the none is, one of those is me because I don't answer the problem. But then we had one student who just didn't answer it. No clear majority here at all. The one most common answer, which is E, is actually incorrect. So, does anybody know how to deal with statement 1? So, you guys are giving, you guys are all, there's this parable about a bunch of blind men feeling an elephant, and they're feeling different parts of the elephant, and so they all report different things, and they're all correct, because they're, the guy who happens to be touching the tusk says, wow, the elephant is really hard and sharp. The guy who's touching the tail says the elephant is really soft and like a feather, and the guy who's touching, you get the point. You guys are touching different parts of this problem. It's like touching the elephant. You guys are all giving me different angles on this. But the best way to do this, I think, is to realize that if you're given a specific digit, sometimes digits can reveal inequalities. Like if you have a particular digit, or if you have the result of rounding a number, which is basically the same thing, then you can sometimes, again, none of this is always, so in case any of you are going to ask, can we always do this? The answer is no. But you can sometimes write an inequality. Okay, if your tens digit is 5, then that means that you are 50 to 59. Notice it's a 3-digit number, but this has nothing to do with the first digit. So we know that the smallest number that'll do that if it's a 3-digit number is blank 50. And the biggest number that'll do that is blank 59. Now, stupid question that turns out not to be so stupid. What is between this and this? Is this n? Yeah, it's n plus 5. This is one thing that is extremely important. The statement is not about n. So you absolutely must think about n plus 5 as a unit in order to solve this. This is very important. If a statement, if the problem makes a statement about, say, n plus 5, don't think about n yet. Think about n plus 5 as a whole. That's supposed to say 5, not 50. Because there's a lot of problems where they do this, right? If the problem tells you about n plus 5, then you have to say n plus 5. I mean, you can just use the words this or that if that doesn't make sense to you. Like the tens digit of that thing is 5. So that thing is between something 50 and something 59. We can't make any direct inferences about n because it's not telling us anything about n. It's telling us about this thing. Does this make sense? Smiley faces if that does make sense, especially from the person who put the question in the text box. Okay, good. So now we can just solve this like an inequality. So We can subtract like we normally do. By the way, you don't have to break these apart to solve them. I know there are some people with the bad habit of thinking that you actually have to break this into two inequalities to solve it. You don't. If you have this kind of thing, you can just subtract 5 from everything at once. So it's something 45 on this side and something 54 on the other side. Yeah. So notice that this is insufficient because some of the 10's digits are 4 and others are 5. So that's not going to work. All right, smiley faces about that. If you have any questions, go ahead and type them in the text box. We're going to get 3 takeaways from this, by the way, so this is really good. So one thing, different strategies that are possible on the digit thing. If you are given particular values of digits, especially digits other than the units digit, or are told facts about the results of rounding, then you can write an inequality. Okay, so for instance, this problem doesn't talk about rounding, but for instance, if I say something like, if I say if n is rounded to the nearest hundredth, the result is 8.04. Then that means that the lowest n can be is 8.035. And then the highest the n can be is 8.045. But you've also got to be very careful because n cannot actually be 8.045. That would round up. But n could totally be 8.035. So in the case of rounding, you've got to be even more careful about these inequality signs, because notice these alligators, because some of them are allowed and some of them are not allowed. But so that's rounding. Rounding is a lot like this, actually. So this isn't going to work. Who knows what's going on in number 2? Text box if you have any insight into number 2. Some people are typing in case any of you guys are wondering about the, yeah, okay, this is it, and then we'll see what a couple other people are typing. The 10's digit changes, that's true, although that's vague. The relationship is a very, very, very particular relationship, and I think Anthony's got a handle on it, but we'll see what you guys are typing. Yeah. That's, Raja, that's it, but that's backwards. You've got the right fact, but you got it written the wrong way. So, okay, here's what you do. Here's an example. Let's cordon this off with an example. Let's say that you have n equals like 854. Then notice that 10n is 8,540. Notice what happens is that you have the same digits, but they're in different places. So I would not memorize this if I were you. I would just pull out an example exactly like this and just watch what happens to the example. So notice that the unit digit of n is the same as the 10's digit of 10n. And then if n has a tens digit, then that's the same as the hundreds digit of 10n, etc. Again, don't memorize this. Just pull out, I mean, unless you're just amazing at memory. Otherwise, just pull out an example like this and use it. It's a lot easier than trying to memorize this stuff. So the tens digit of 10n is just an obnoxious way of saying the units digit of n. Those are the same thing. So tens digit of 10n is just code for the units digit of n. And the reasoning behind that is here. And that is, of course, only a single example, but it's pretty clear that it'll always do the same thing. You're just taking in stuff and moving it over by one. Does this make sense? Smiling face if this does. So what this is saying, in other words, is basically just that the units, the tens digit is less than units digit. There's all kinds of ways you could do that. You know, I don't know, 1, 23, 35, 89, 17, 06, etc. This is definitely insufficient because the tens digit can be anything except 9. Now, the only way this can't work is if you put a 9 in that digit, because then there's no digit that's bigger than that. This one you really can't solve with algebra. It's impossible to do this with algebra. It's just not going to work. So some of you guys are trying to write equations. The equation's not going to fly here. Any questions about this? So this is not going to be sufficient either, so we need to look at them together. If we look at them together, does anybody know how we do this? How do we combine these statements? So someone was accidentally on the microphone there. I apologize for that. You guys are barking up the right tree, but one student wrote it has to be 45. That's not true, but you're thinking the right way. But this is not two possibilities. It doesn't have to be 45 or 54. This is actually a whole range of numbers, but you are thinking the way you should be thinking. The only really feasible way to do this is just make a list of all the possibilities. Okay, so if there's anybody out there in the audience who absolutely depends on algebra for all of their sustenance, you guys are not going to like this. But really the only way to do this is just to make a list. So from statement 1, you have these possibilities. There's everything. Those are the only possibilities. So all you do is just list them and then kill the ones that don't satisfy statement 1. That's statement 2. Or better yet, just think of it as keep the ones that satisfy statement 2. Kill the ones that don't satisfy it. Keep the ones that do. So the only ones that have the tens digit less than the units digit are these. So the question is, what is the tens digit You can't find out what the number is, but if you look at the tens digits, they're all the same. All of the tens digits are 4s. So this is going to be sufficient. Notice this is also generally the way that data sufficiency works. You can't find the number, but the tens digit has to be 4. So that's sufficient. And so the answer is C to this problem. So let's get some takeaways here. I've answered in previous study halls that there's only one answer to what number is the difficulty level here, and that answer is it doesn't really matter as far as studying is concerned. So I'm not going to give numbers to that. But the 30-second answer to, if you've been to these study halls before, this will be old news to you, but thinking about difficulty levels when you study is absolutely destructive to your studying. It's not going to help in any way, and it will inhibit your study in several ways. It's not going to help because difficulty levels, who cares? I mean, when you take a test, it's not like you have those. So you don't want to start thinking about things that you're not going to know on the test anyway. So that's number one. But number two, more importantly, if you start thinking about difficulty levels, then you're going to care more or less about a problem depending on its difficulty level. And that's horrible because the point is not the problem. The point is all the things you learn from it. So regardless of whether you think this problem is easy or hard, it doesn't matter how hard this problem is. It doesn't even matter really if you get this problem right or not. All that matters is that you learn the things that are takeaways from this problem. So if you're even asking for a number as a difficulty level, that means you've got the wrong priorities as far as studying for this test. So just make sure you guys are aware of that. It's not how hard is this particular problem, because you don't care about this particular problem. All you care about is what can I learn from this problem that will then work on other problems. So let's type some things that we learned from this problem. One thing is inequalities. Another thing we learn is you should be aware of the relationships between digits in a number, especially if you multiply or divide by 10 or powers of 10. So like this sort of thing here. And then finally, you may have to just list everything in some situations. So if you have only a small number of possibilities, then don't necessarily rely on algebra or theory. Instead, if you don't think of something, then just start making a list. So highlighting things that are most important here. Particular values of digits can sometimes give you inequalities, or if you talk about rounding. Relationships between digits when you use powers of 10. If you have small numbers of possibilities, a lot of times you can make a list. You got one or two people saying, let's go look at this again. Let's take a poll here, because there are 25 people here. So give me a smiley face if you are okay with this stuff, and give me a frowny face if you think you need to look at it again. Okay, we've got a lot of smileys and only about 5 minutes left in the study hall. So if you have trouble, I wrote this problem, so if you want to post this on the forum, you can. If you have issues with this particular problem, then you can post it on the forum in the general math folder. But we have a solid majority of the study hall here gave me a smiley face, so we're going to need to move on to one more problem about digits. If you do have trouble, though, go ahead and post a post on this in the forum. And that's this. The recordings are usually available in the next few days. I don't know what the exact schedule is, but you can ask tech support at manhattangmat.com if you need to know. Here's the address for the forums. General math problems folder, and be sure to cite the source. In this case, the source is study hall with today's date, because then we know it's legit. Okay, let's do one more example, and then we'll call it a day, which is going to be this one. That's the wrong problem. We didn't get to that. Okay, try this, and I'll give you the timer again. Again, when you get an answer, please go ahead and indicate it in the box, not in the text box. Buttons up at the top left of the screen. Thanks. Okay, I mean, by the way, guys, these are obviously hard problems. I mean, we don't need numbers as difficulty levels here, but the problems are not easy, so you don't need to feel bad if you're having trouble with them. Go ahead and give me an answer in the next 10 seconds or so. That was about 2:20 already. Yeah, also, we don't have these. I mean, I wrote these two problems myself, so, and they're eventually going on the CAD, but we haven't calibrated them yet, so they're hard. Okay. Go ahead and indicate an answer if you are Belinda or Priyanka. We've got, okay. I don't think Belinda is here because she didn't answer the last question. Here is your point. Here are your results. Again, this is almost everybody picked these choices almost evenly. Yeah, these guys, these are hard problems. They're hard. So if you struggle with questions, that's understandable. They're not easy. And also remember that even if you guys do a really, really good job on this exam, don't forget that you will still be struggling with almost all the questions. They're going to be hard. So that's the way this test works. I mean, you should be used to it throwing obnoxious things at you and you having to just kind of run to keep up with it. That's what adaptive tests do. So if the problems are freaking you out a little bit, it's good that you're becoming accustomed to that sort of difficulty level and not just solving things that are easy. So be aware of that. It's better to have your nerves spooked out a little bit now than on test day. So yeah, not entirely a bad thing. So a lot of people are basically guessing here. In this case, you can do algebra, but let's say we'll go over that in a second, and I'm gonna try and give you the executive summary here because we're starting to run over time a little bit. Let's say you didn't figure out the algebra because, well, I mean, we'll cover the algebra in a little bit. Who knows what you can do if you didn't figure out the algebra? Text box. That's the algebra. So, yeah, you just start plugging in numbers, right? And exactly. I mean, this is absolutely huge. You guys have really got to know this. So if you can't figure out anything else to do, then just start plugging in values and looking for patterns. Okay. Do not waste 2 full minutes hacking at algebra that is not working. I mean, if you don't figure out an algebraic method in the first, I mean, if you don't figure out a start to this in like the first 20 or 30 seconds, don't just keep pushing numbers around the page for 2 minutes. I mean, you instead just start plugging in values. Because especially with digits, digits are patterns. Like digits are basically just things that have lots and lots of repeating patterns. So let's just try stuff. Let's just try some random numbers. That do what the problem says. So who in the text box, who can give me some random numbers that do what the problem says? 3-digit positive integers whose digits are the same but in reverse order. 841 and 148, and 321 and 123. This doesn't mean numbers like 101 necessarily. It means because whose digits are the same but in reverse order. That means that digits of x are the same as digits of y, but they are reversed. So, right, like the examples in the text box are good. 122 and 221, or 102 and 201, or not just 908, but 908 and 809, 321 and 123. So let's just try these. So let's say x is like 123 and y equals 321. Well, all right. The difference is 198. So there goes C. Okay. Let's just try the ones that are in the window. X equals 122, y equals 221. Difference is 99 by choice B. And then somebody wrote 101. If X is 101, then what's Y? Yeah, 999, same kind of thing, right? So the difference between those numbers is 0. So by choice A. So let's see if we can find any patterns here. I mean, we don't 009 is not a 3-digit number. Make sure if you need that as a takeaway, make sure you get that. But 9 is a 1-digit integer. 9 is not a 3-digit integer. So, yeah, if you look at this, I mean, if you try a few more examples, you could just keep bombing it with examples until you knock off a bunch of numbers. So, like, if you do x equals, I don't know, like 512 and y equals 215, then your difference is 297. That doesn't knock off anything. So here you can do 2 things you can do. Number 1, try to recognize a pattern. In this case, the pattern is all of these are multiples of 99. Now that's not, I admit that's not the world's easiest thing to see. So if you don't see that, the other thing you can do is just keep bombing the problem with numbers until only one choice is standing. So let's just keep, I mean, if you just keep doing that, then, you know, eventually you'll get to something like this. 801 and y equals 108 or something like that. 841 someone put in the box, so let's use what people are putting in the box. So if you do that, then the difference is 693 by choice D. So E wins. Really, a lot. I mean, this is very much not an easy problem, but if all you do is bomb it with a bunch of subtraction, then you can solve it. And there are lots and lots of problems that are like this, that you can just throw numbers at them until they finally confess. Does this make sense? Smiley face if it does. And I mean, any of you who pushed variables around a page for like 2 minutes, take a long, hard look at this method because it works and all you have to know how to do is subtract. Elaborate the significance of it. Well, it's a pattern. I mean, this is something you would notice about these numbers. So I mean, we'll discover why this happens in the next slide. But if you're plugging in random numbers, you do not care why things happen anymore. You stop caring about that. Because think about when you do this. You do this when you cannot figure out why stuff happens. So, question in the box, what about the algebra? Is it easier? It doesn't matter if it's easier. I'm going to go ahead and type this in the text box too. Because plugging is what you do if you can't figure out the algebra in the first place. So it doesn't make any difference if the algebra is easier, because if you don't know how to do it, then you don't know how to do it. So, you guys see what we mean. I mean, remember, you cannot have this attitude that you must be able to do everything with algebra all the time, because there are problems that you cannot do with algebra, like this. The only way you can solve this last problem, which admittedly is pretty hard, is to list stuff at the end of the problem. So you really, really cannot have a one-track algebra mind here. Otherwise, they will throw problems like this at you, and you will die. So, but in this case, you actually can do algebra. So let's do that, and then we're already about 8 minutes over time here. So I'll give you the quick version, and then we'll be out of here. Okay, here's the algebra method. What you've got to know how to do is you've got to know how to write digits as algebra. Okay, so for instance, in grade school, when you first learn about 3-digit numbers, they teach you that this 5 is not really worth 5. How much is this 5 worth? It's actually 5 what? It's actually 500. So it's actually 100 times 5, plus that's actually 10 times 3, plus that's actually 8. Okay, this is what they teach you in grade school when they're like, guys, here's how 3-digit numbers work. Because for kids, that's hard. I mean, kids see 5, 3, 8, and they think that means 5 plus 3 plus 8. And so you have to school them in this kind of stuff. Now, in grade school, you're not going to use algebra, obviously, because grade school kids aren't going to know what you're doing. But if you have digits like L, M, N, it's the same sort of thing. That's 100L plus 10M plus N. So this is how you have to know how to write this sort of thing. Okay, smiley face if this makes sense. It's just like 538, but it's with L and M and N, or whatever you choose to call them. So let's do that. The algebra method is the reverse order digits. So X has digits L, M, N. And then Y has the same digits in reverse order, so that's N, M, L. So X can be written as 100L plus 10M plus 10M plus N. And then Y can be written as 100N plus 10M plus L. So we don't know which way the difference is. So if it's X minus Y, or if it's Y minus X. So we'll just work it out both ways because we don't know which way it is. That's 100L plus 10M plus N, and then Y is L plus 10M plus 100N. So if you subtract, then the difference is 99L minus 99N. There's not supposed to be an S there. If you do it this way, then it's Y on top. So that's Y is 1L plus 10M. plus 100n. And then x is this. So in this case, the difference is going to be the other way around. So notice that both are multiples of 99, but the problem here is that all of the choices are actually multiples of 99. So the algebra here is kind of a fail. It doesn't really solve the problem, which is the point, because all of these, including 0, are multiples of 99. So, well, what we do is we say, all right, let's just try to, like, let's think biggest, smallest. What's the biggest this can get? Like, I mean, someone in the text box, give me the two numbers that are going to have the biggest possible difference. Those are not 3-digit numbers, though. 999 is not. If you use 999 and 100, you can't use because those are a lie. I mean, you have to make this true. You have to be reverse digits. So 999 is not reverse digits of 100. So 901 and 10. You have to have a 9 and a 1, otherwise it's not. So 901 and 109. Or 911 and 119. Or 921 and 129. Or etc. But that's the way you're going to make this difference as big as you can make it, is to put a 9 and a 1 there. In these cases, the difference is 792. So you can't get a difference as big as E, which is not going to work. So there you go. You actually can realize this with algebra, but only if you are incredibly insightful about this. Let me show you that, and then we're going to quit. This is sort of advanced, but I'll show you how to do it. If you understand number properties pretty well, this will make sense. You can factor these expressions. This either gives you 99 times L minus N or 99 times negative L plus N. And that one on the right turns into 99 times N minus L. Notice that the biggest that L minus N or N minus L can be is 8, not 9. Because 0 is not allowed to be these digits. So the farthest apart you can make them is the split between 1 and 9. So the biggest value you can get is 99 times 8, or 792. That's what we found here. So if you understand this kind of number properties, you can do that. If you don't, it's not really a problem because you can just test stuff. Okay, we are 16 minutes over time, so we've got to quit. If you have problems about this other problem, go ahead and post them. This one, go ahead and post them on the forum. Remember, if you're going to post these things on the forum, please cite the source as today's study hall, because if it's in today's study hall, then it's legitimate. So, okay. Go ahead and quit out of the program, please. And if you have extensive questions, which slide are you at? This slide? Okay. All right, so that's it. I don't really decide what goes in these until a day or two before, because people submit problems. So the answer to what's in the next one is I have absolutely no idea yet, because people haven't submitted problems. So, okay. This one, we already did a whole study hall on combinatorics, so we're probably not going to do that again for a long time. Because so if you look through the archives, you'll find it. But there's one session we did that was all combinatorics. Okay, I'm going to move from this slide to the 7-step method, and then we're going to quit pretty soon. So here's the 7-step method. Okay. For verbal timing, just send me an email at the following address. I have a forum post that I wrote on that. I'll just send you a link to it. Because verbal timing is just numbers. You really don't need to do that in the study hall. But I'll send you a link to. I wrote about that in the forum. So for timing, just send me an email to that. Okay. I'm going to log you guys out in the next minute if you don't quit. So you can just close the window. You don't have to. You don't have to log out or anything like that. But yeah, all right. Good luck, guys, and thanks for showing up.